Hello and welcome. In this video we are looking at the life cycle of stars, and we're going to see what happens to stars that are roughly the size of our sun and what stages they go through, and we're going to look at stars that are much bigger than our sun and the stages they go through in their life cycles. Now it's probably a good point to start with or a good place to start is with the Big Bang. So about 13 billion years ago is when the Big Bang happened, but shortly after the Big Bang, I say shortly, 100,000 years in the scale of the universe is not a very long time at all, but after about 100,000 years we had the production of some of our lighter and smaller elements, and the main ones for these were hydrogen and helium. So for a very long time the universe consisted only of hydrogen and helium, maybe one or two other light elements, and not much else. There were no stars, no planets, and for a very long time these were the only two elements, the main two elements that were around. Now these two elements having a mass, even though it's a very tiny mass, have gravity, a very tiny amount of gravity, but as they start joining together and getting closer together, that gravity increases more and more and more, and over a few billion years these two elements were actually able to produce these things called protostars, and this is the starting point for the life cycle of stars. So we're going to have a look at that now. So here is our protostar, and I've just kind of drawn it as a giant cloud of, they say dust and gas, but it's these small particles, these hydrogen and helium, which are slowly coming together and getting closer and closer together with increasing gravity as it goes. Now a large enough one of these clouds will produce a star, but we also have smaller clouds of these particles that could go off and produce planets, and these planets would be attracted to these larger protostars that become actually stars and can then orbit around. In terms of our protostar, we've got this giant cloud of these particles which are getting closer and closer together under the force of gravity, and it will get to one certain point where we have what we call the main sequence star, and I've written the word, it's supposed to be fusion here. There you go, that's a bit neater. Now what's happened is that the gravity has increased so much within this star that the hydrogen that's in there, the vast amounts of hydrogen that are in there, are able to actually fuse together because of that large gravity and the large temperatures that have been achieved, and actually this process of fusion happens. And this is during the main sequence of the star. We have two opposing forces that are going on with this star. There are the forces that are pushing outward, caused by the nuclear reactions, and there are forces pushing inwards caused by gravity. So these two forces balance each other out, and the star stays around about the same size, and it's a main sequence star. So the force of gravity is equal to the force caused by the nuclear fusion reactions that are going on inside the core of this star. Now what can happen is the star can then actually start to run out of this fuel that it uses, this hydrogen, and it does take often billions of years for this to happen. So it stays in this sequence for billions of years, but eventually that hydrogen will start running out and these fusion reactions become less and less, and the next stage for this star is the swelling into what we call a red giant. This is when the star is approaching the end of its life cycle. So a red giant is the main sequence star which swells out, and that will eventually run out of its fuel, and that will then shrink into what we call a white dwarf. It will collapse under the force of its own gravity. So gravity plays a lot of parts in the life cycle of stars. It will collapse under the force of gravity. It will still be very hot, but then it will then over time, because there's no fusion reactions going on, cool down to produce what we call a black dwarf. Now this is what happens with stars that are roughly the size of our own sun. Stars that are much bigger go through a slightly different cycle, and we're going to look at that now. So we start in a similar way with our protostar, which is our giant cloud of these particles, and the next stage is, again very similarly, it becomes a star, a much larger star than our sun, but we still have the forces being balanced by the force of gravity and the force of nuclear radiation being balanced, and again for billions of years this star will stay in what we call the main sequence. The next stage after that is that it becomes not a red giant, but because it's quite a large star, when it swells it becomes what we call a red supergiant, which is a much larger body than we had previously. Now what can happen next is this giant red supergiant can actually begin to collapse, and it collapses more and more and more, and at a certain point during that collapse that is reversed in a massive way, and we have this thing, this event called a supernova, which is the best way to describe it is like a giant massive explosion which generates tons and tons of heat and light, and it's called a supernova. Now, a supernova is quite an important event because what it does is it actually scatters the elements that were produced in the star throughout the universe. So all the elements that are produced from the fusion of the small nuclei are scattered throughout the universe. During the life cycle of stars, you often get elements up to the mass of iron that are produced, and these are produced in the center of stars. But during our supernova, we can get heavier elements, and that can go all the way up to gold. But you can see that not every star ends its life with a supernova, and the gravitational forces required to produce fusion into these heavier metals doesn't happen in every single star. So you can imagine that elements like gold are slightly rarer in the universe than iron, and those are with the mass below iron. Okay, so we have our supernova, and after that we have one of two possibilities. If the star is very, very massive, we're going to get the production of a black hole, but often it can lead just to a what we call a neutron star, which is a body just made of neutrons, and which is the next stage after the supernova. So one of these two events can happen. It can either be a neutron star or a black hole. This is for massive stars that are very, very large, at the larger end of the scale. And a black hole is basically a very, very dense body in the universe, probably the densest body that exists, and that will attract anything that's near it. It doesn't allow anything, the gravity is so large it doesn't allow anything to escape, not even light. Now, it's probably a good idea to have all this summarized in a slightly neater way. So here we have a slide that shows the two pathways, and unfortunately you have to actually know these two pathways and remember them and be able to draw them. But what we have is our protostar and main sequence star. That's common to both of our life cycles, and if we have a star that's about the same size or smaller than our sun, it's going to go down the red giant, white dwarf, black dwarf pathway. If we have stars that are larger than the sun, then we're talking red supergiant, the supernova, which can then produce our neutron star, or for very large stars, our black hole. Okay, so you need to know these two sequence of events. You need to know about the production of the heavier elements, the fusion of the smaller elements, hydrogen, helium, and those small elements into the larger elements up to iron, and the production of the very large elements with the big mass such as gold during the supernova stage of the sequence of a star. Anyway, that's me done for this video. Thanks for watching, and I'll see you again soon.